Hello everyone. As part of learning generative AI, let us look at some more concepts on attention mechanism. In the previous session, we have seen the introduction to attention mechanism, the necessity of it, and where it is leaping us the advantages. Let us see some more concepts on the same concept, that is attention mechanism. The attention mechanism, it was introduced to take over the limitations of the vanilla sequence to sequence models and give us the most possible advantages. What it does actually, it allows the model to focus on different parts of the input sequence, and it is trying to allow the model to identify the relevance of an input parameter, and we are not simply based on fixed size single context vector for a long input sequence. So how the attention mechanism is working on sequence to sequence model? The first phase is the encoding. The encoder, what it does is it takes the input sequence and processes it through an RNN and generates the sequence of hidden states. It will try to generate a sequence of hidden states, one for each input token. Say for example, I have 20 input tokens, I will get 20 hidden states. It's pretty clear. These hidden states collectively represent the information of input sequence at different time steps. What do I mean by that? At one particular point of time, how am I using the input sequence? Next context, how it is used. So at different time steps, what is the information of the input sequence? That will be kept into these hidden states. Then for each time step of the decoding, so it has come to the decoding phase. For each time step of the decoding, what are we trying to do is the decoder will not use the final encoder state. What it will do, it will compute a set of attention weight for each hidden state which is generated by the encoder. So we are not simply taking the output that is coming from the encoder, and instead what are we trying to do? We are trying to compute attention weights for every hidden state generated by the encoder. These weights are calculated using a score function. And what this score function is trying to do? It is trying to compare the current decoder's hidden state with each encoder's hidden state. So the decoder is trying to process the hidden state and it is trying to compute the score. What it is trying to do is it is trying to compare the hidden states which is generated by the decoder with the encoder's hidden state. Various scoring functions like dot product is there, concatenation is there, cross product methods are also there when you are trying to work with vectors. Because here you are talking about context vector, we try to work with the vector operations like dot product, cross product, etc. And sometimes we can also use a feed forward network. Then context vector, after it is trying to compare the hidden states score function values, what it is trying to do is the attention weights are applied to encoder's hidden state and we calculate a weighted sum. That weighted sum is called as the new context vector. This new context vector represents relevant parts of the input which are to be considered, which are not to be considered for the current time step of decoding. What does the decoding do? The decoder combines its hidden state with newly computed context vector and it will try to predict what could be the next token in the output sequence. So whenever you are trying to do this kind of decoding, the decoder is trying to attend different parts of the input sequence, and by which the model is becoming highly flexible and it can handle longer input sequences and also complex input sequences easily, wherein the previous mechanism like vanilla sequence to sequence models were failing to do the handling of larger input sequences and complex input sequences. So this is just a simple method which I tried to summarize the computation mechanism. Encoder is trying to calculate hidden states for every input token. If you see, I have n number of input tokens, I have n number of hidden states, h1, h2 and so on, which are passed on to the encoder. Then the decoder time step, what it is trying to do is, it is trying to assign weights to, what type of weights? Attention weights to all the encoder's hidden state. So if you see, I is a variable here, you are trying to work with t as at present time step. You are trying to calculate the score, which is a function of the previous state, that is t minus 1, and hi. For the current hidden state, you are trying to calculate the score. Then after calculating the score, what are we trying to do? The weighted sum. So we are trying to work with the summation of the weights of, or the scores that are calculated in step 2. You are trying to find out the weighted sum of the encoder hidden state. Then what are we using? This output from the step 3 is the context vector CT. So using the context vector and the decoder hidden state calculated in the step 2, we are trying to predict the output token. So whenever you are trying to incorporate the attention mechanism, the sequence to sequence models are more powerful and accurate when compared to previous sequence to sequence processing models. Now sequence to sequence processing with attention mechanism, let us try to put it in more concrete words. A sequence to sequence with attention model enhances standard sequence to sequence architecture. How are we trying to do this? By allowing the decoder to focus on not all parts of the input, but only specific parts of the input sequence. From the beginning, we are trying to concentrate on the same point. We are not allowing the model to pass through every input token. We are trying to make sure which parameters are relevant to us. We are trying to pick them, and the decoder will process through only those input tokens. So what are the key components of attention mechanism under sequence to sequence? You need to have an encoder, right? What does this encoder do? It processes the input sequence and it is trying to generate hidden states. How many number of hidden states? Which is equal to the number of input tokens. Next, we need to have the attention mechanism which is trying to compute the scores for each and every hidden state which is calculated by the encoder. Then you need to have at the decoder step, context vector is to be calculated as the weighted sum of the scores calculated for the hidden states. Then the decoder is trying to use the scores of both step 2 and step 3 in order to predict the output token, right? And encoder, decoder, attention. What is the concept, right? The encoder, decoder, attention, it's a very critical component in attention-based sequence to sequence models. Specifically, when you are trying to work with models like a transformer, what it is trying to do is, it is allowing the decoder to specify which input parameters are relevant and which are to be encoded, then encoding all the input tokens, right? And we are trying to decode only those tokens which facilitate better translation of the information from input to output. How the encoder-decoder attention works? Encoder is processing the input sequence and generates a sequence of hidden states. We understood this. Then these hidden states are representing the input sequence in a transformed space. Under decoding, what are we trying to do? It doesn't simply rely on its own previous hidden states, but it is also considering the hidden states of the encoder. If you remember how the function works, second step you concentrate. You are trying to calculate the hidden state at the decoder, alpha ti. What it is a function of? It's a function of previous hidden state at the decoder, that is s of t minus 1, comma hi. What is hi? At ith step, what was the hidden state from the encoder? So, come back to this one. The hidden state at the decoder, it is not simply relying on its own previous hidden state, but it is also considering the hidden state of the encoder. And the attention weights are computed between current decoder hidden state and each of the encoder hidden state. And what help these weights are doing us? These weights are helping us to know which parameter should be considered with high weighted value, that should be considered, and the inputs with low weights should be neglected or can be neglected. Context vector, it is the weighted sum of the encoder's hidden state. And what are we trying to do with the context vector? The context vector is summarizing the relevancy information from the input sequence for the current decoding step. The context vector combined with the decoder's hidden states will try to help us to predict the next token in the output sequence. What is the key idea here? The encoder-decoder attention allows the decoder to dynamically attend to various parts of the input sequence. See, we are not going through by every sequence or every token of the input sequence. We are trying to skip some of the tokens. So we say the decoder is dynamically attending different parts of the input sequence. This is particularly useful when we are trying to work with translation of languages. Example use case: whenever you are trying to work with a translation task, when you are trying to generate a word in the target language, say for example I am trying to translate from English to Hindi, say for example, the decoder uses encoder-decoder attention to focus on most relevant words from the input sentence, and it will try to ensure a more accurate translation is generated, right? And the transformer models not only are able to process long sequences, not only they are doing or very well with long sequences, but they are also doing parallel processing of simultaneous parts, right? Thank you.